Hello students, Tom Simmons here with another installment of Economics with Tully. This is video 3.2. In 3.1, I reviewed the concepts of elasticity, and we just went over the concepts. As you remember, elasticity is a way to measure or a way to look at how sensitive one variable is to a change in another variable. So for instance, we know from the law of demand that if the price of a good increases, the quantity demanded of that good will decrease. That in and of itself does not prove elasticity. That simply proves the law of demand. The concept of elasticity drills down a little further and asks the question, all right, if consumers are reacting to a price change, how significantly are they reacting? Is it swift, is it strong, or is it just a little bit of change in habit? And if they only change their habits a little bit in response to a change in prices, the good is said to be inelastic. And if a small change in price results in a significant change in the amount of the good they want, that's considered to be a highly elastic good. But we've only talked about that in terms of concepts. Today, I'm going to use this video to convey the math, the algebra, the graphs. So, let's take, we're going to take an example of demand in a particular store. And for the lesson we're doing today, it works best when you're looking at the market in a single store or a single retail outlet. And we're going to look at the market for bags of almonds within a particular supermarket. And the supermarket has 2 points of data. The supermarket normally sells these bags of almonds for $6. And as a result, they normally sell 20 bags of almonds. Then they had a sale and they reduced the price to $2. And they found that they sold 60 bags of almonds. So we have 2 points of information here. 2 combination of price and quantity. Is it elastic? Is it inelastic? Do we just guess at it? No. We apply numbers. We apply quantitative measurements to the information we have in order to make this determination. Now, what I've set up behind me is a very simple, typical graph. If you'd like to take notes during this video, and you think it might be a good idea, and it probably will be, to have a copy of this graph, I recommend you stop the video and copy exactly what you see. As is typical of all graphs in economics, price is on the vertical or the y-axis. So we've labeled the prices $1, $2, $3, $4, $5, $6, $7, $8, $9. And as is standard in all economic graphs where price and quantity are the 2 variables, quantity is along the bottom or the x-axis, and I calibrated these in increments of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So, if you'd like to make that graph and copy it, now would be the time to stop and just make a quick copy. Now, as I said earlier, we have 2 pieces of information, 2 points of data. We know what happens when the store sells these bags of almonds at $6 and what happens at $2. So let's plot those points right on the graph. At a price of $6, the supermarket sells 20 bags. $6, that's the $6 line, that entire horizontal line. 20 is the quantity. Where they intersect gives us a point of data, a known point of data. The other known point of data that we have is that when they dropped the price to $2, they sold 60 bags. $2, 60 bags. Known piece of data. Now, when we're working in economics, What we're now going to do is connect these 2 points of data. And we're not going to do it just by drawing a wild line because we think our hand is good enough. We're not going to do it simply by taking a ruler and connecting dot to dot, because chances are we're not going to put that line where it belongs. What we're going to do is look at the slope between these 2 points. And by slope, I mean how many lines down do you have to count and how many lines over do you have to count in order to get from one point to another. Think of it as a type of video game almost. How many streets do you have to cross down and then over? In this case, it's 1, 2, 3, 4 down, 1, 2, 3, 4 over. Well, as you all know, 4 over 4 as a fraction actually can be reduced to 1 over 1. And that means the slope of this line is 1 over 1. 1 over 1, known point. 1 over 1, known point. 1 over 1, known point. And when we begin to connect the points of data, we can extend beyond the points about which we know, because we know what the slope is. So we can continue this line down by going 1 down, 1 over, 1 down, 1 over. And we can continue the line up in this direction, 1 over, 1 up, 1 over, 1 up. And that represents the demand curve for almonds within our particular supermarket, the one that we're speaking of. So once we've got those known points, let's connect them, and now we have a demand curve. So this dark blue curve that I just drew represents consumer demand for almonds in the store. And now we're going to look at this curve and pull data off of it in order to measure price elasticity. Once again, yes, we know that as the price decreases, the quantity demanded increases. That in itself should not make you say, oh, it's elastic, because all goods have that relationship between price and quantity. We need to quantify how sensitive is the consumer's change in the quantity they purchase to the change in price. In order to do that, we can pick any 2 random points on this curve and calculate the elasticity between, the price elasticity specifically, between these 2 points. So, I am going to choose the $6 level, meaning that point right there, circled in red now, and the $4 point, circled in red. And I'm going to calculate the elasticity, the price elasticity, between those 2 points of data. So we're measuring the elasticity of the curve given those 2 known points. Now, the most important thing to extract off the graph are the prices involved and the quantities involved. And you'll notice that for the purpose of this demonstration, I'm not using the 2 points that we were originally given, and I'm doing that for a reason. The 2 prices involved are clearly $6 and $4. The quantities involved at those prices would be 20 and 40. Once you know the 2 quantities involved and the 2 prices involved, you can conduct the math necessary to measure the elasticity. So I'm going to slide the video over to where I've done the calculations for this particular segment of the curve and walk you through it step by step. Don't freak out. Step 1. Identify the prices and the quantities about which we're concerned. I've done that in step 1. The prices are $6 and $4. The quantities were 20 and 40. Step 2 now requires applying the formula. Now there are a number of different formulas that can be used to calculate price elasticity. In general, they all function by taking the percent change in quantity divided by the percent change in price to try and see how sensitive is this consumer change when price changes. There is one particular formula that I prefer over the others called the midpoint or the arc formula, which is long and complicated when you read it in a book, but when you boil it down to normal human being terms, it really is as simple as this, and that's step 2. It is the change in the quantity, and I always use a delta or a triangle to indicate change. The change in the quantity divided by the average quantity over the change in the price divided by the average price. And you forget about negatives. Don't even worry about them. They don't exist. So you have this long formula if you look at it in the text, but this is really all that formula is saying. So when we apply that formula to the numbers we have, the change in quantity is the change between 20 and 40. Well, what's the change between 20 and 40? Well, it's 20 units. Divide that by the average quantity. What's the average of 20 and 40? Well, the average of those two numbers is 30. So your numerator, change in quantity divided by average quantity, is simply 20 divided by 30. Now we do the same thing for price. The change in price is the change between $6 and $4. Well, what's the change? 2. 6 minus 4 is 2. There it is. What is the average price of those two prices? Well, the average of 4 and 6 is 5. There it is. When you calculate the numerator and the denominator out separately, which is what you must do, 20 divided by 30, 0.67. 2.5, 2 divided by 5, 0.4. And when you finally take those two numbers, 0.67 divided by 0.4, you get a price elasticity of demand of 1.675. At which point, you say to yourself, what does that mean? Price elasticity is 1.675. Woohoo! 1.675 what? It's not dollars, it's not quantities, it's not cents. It's price elasticity measurement. And here's the rule of thumb that we use. If we calculate price elasticity and the resulting number comes out greater than 1, the good is said to be elastic in that price range, meaning a small change in price or a change in price will result in a significant change in consumer behavior. Consumers will react significantly. It's elastic. If that number comes out less than 1, then we say it's inelastic, meaning consumers might change their habits, but not very much. If that number comes out to precisely 1.0, we have reached a very interesting place that we're going to spend more time talking about, called the unit elastic price. And that is the point at which consumers' response is entirely proportional to the change in price. So prices went up 20%, consumers dropped purchases 20%. It was an entirely proportional approach. So you've got elastic for over 1, unit elastic, or proportional, for equal to 1, and inelastic for under 1. Now, let's move back to the graph, and I'm going to put that elasticity measurement right on the graph so we can compare it to elasticity elsewhere on the graph. We determined that this elasticity was 1.675. And here's what may be really intriguing to many of you. This line, it's a straight line. It has a constant slope. It goes from corner to corner to corner to corner the entire way. So you might be tempted to think, oh, okay, well, this elasticity is 1.675. Almonds must be elastic in this store. Don't fall for that, because the elasticity of this good, even though it's a linear curve with a constant slope, changes depending on the precise price level you are measuring. Let's take another price level, and I'll walk you through the calculations from scratch. This time, let's look at the price elasticity between $3 and $1. This point and this point. So we're in the lower half of the graph. So we're going to measure it right there. So, first thing you do is pull out the prices involved and the quantities involved. Prices involved, as I said, with $3 and $1. So we're going to add those right up here. $3 and $1. At those prices, what are the quantities involved? Well, at $3, we have a quantity of 50. At $1, we have a quantity of 70. Therefore, our two quantity numbers, 50 and 70. And 70. Our formula remains exactly the same. Change in quantity divided by average quantity over change in price divided by average price. So we're going to need to change these numbers. So, you take a look at this for a second and tell me what numbers I should be filling in here. Well, the change in quantity, the change between 50 and 70, is a change of 20 units. And we're going to divide it by the average of those two numbers. What's the average of 50 and 70? 60. It's the midpoint between the two numbers. If you didn't know that, or it didn't automatically come to you, you add those two numbers together and divide it by 2. You got 60. Price. Change in price from 3 to 1? Well, it's a change of $2. Average? Well, the average of 1 and 3 is 2. So, now we do our math. First thing we do is take 20 and divide it by 60 for our numerator. And the answer we get, 0.33. Denominator, 2 divided by 2. You can do this without a calculator. 1. 0.33 divided by 1. Our answer is 0.33. price elasticity of demand is different at the lower price range. Let's add that into our graph. This is 0.33. So let's look at this for a second. When we measured elasticity using our formula in the higher price ranges, we came out to 1.675, which meant it was elastic. There was a significant consumer response to a change in price. When we did that again in the lower price levels, it came out to 0.33, which is less than 1. And that means in those price levels, it is inelastic. There's not a significant consumer change in habits as a result of a change in price. And even though this is an entirely linear, constant slope demand curve, I can tell you that the elasticity measurement, the price elasticity, between any 2 points along this line is different. In fact, a pattern will begin to emerge. It always does. And the pattern is this for every good and service. All of them. The higher the price, the higher you raise prices, the higher the elasticity and the more elastic the good gets. The more significantly consumers respond, positively or negatively, to a drop or a rise in prices. The lower you go in the price for that good, the more inelastic it gets. Meaning you can drop the price just a little bit more, and you really don't make that much more sales. Or you can raise it, you can double it from $1 to $2. You don't lose half your sales. The price is already so low, consumers are still willing to buy it. Every good and service will exhibit this phenomenon along its demand curve. The upper price ranges will give you a high elasticity. The lower price ranges will give you a low elasticity or an inelastic measurement. Somewhere between the inelastic and the elastic, you will find the point known as unit elasticity. Now, I'm going to make this easy for you and not go through another set of calculations. I'm going to tell you where it is. And if you want to calculate it on your own, God bless you, go for it, because you're going to have to do it in homework anyway. If you take the $5 level and the $3 level and measure right there on that arc, I promise you, you will come out with exactly 1.0. Now, how come I kept doing $2 increments? Right? I did 6 to 4. I did 5 to 3. I did 3 to 1. One of the reasons I did that was because, to be very, very technical, when you're finding elasticity, you're finding it in a range. You're finding it on a part of the curve. But also, technically, you can say that the price that is directly in the middle of that arc that you're measuring has that particular price elasticity. In other words, you can say this good has a price elasticity of 1.675 in the range between $4 and $6. You can also legitimately say that the price elasticity at $5, which is the midpoint of that range, is 1.675. And that's why I did this, because now you can see that while the elasticity is exactly 1 between $3 and $5, We can also say that the elasticity is precisely 1 at the price of $4, which is the midpoint. In fact, $4 is said to be the unit elastic price for this particular good. Now, what does that mean outside of the fact that consumers have a proportional response to a change in price? Well, now, instead of looking at consumer reaction, let's take it the next step. When consumers react, they have an effect on the producer, don't they? Because when producers buy more or less of a good, they are giving the producer cash, or a credit card, or a check. They're putting money into the producer's cash register. So their willingness to go along with a change in price or to shy away from a change in price affects the amount of money in that store's cash register. That particular measurement is a measurement of revenue. Now we're looking at it from the store side instead of from the consumer side. And when we add up all the dollars in the cash register at the end of the day, we call that total revenue. And I would like to show you another pattern that will evidence itself by calculating total revenue. Let me get my green marker. If this supermarket prices their almonds at $8 a bag, how many will they sell? Well, the demand curve tells us that at $8, they ain't selling a thing. Consumers say, forget it, too much. If they sell at $7, consumers will buy 10 bags. So now tell me, how much will be in the cash register at the end of the day as a result of $7 bags of almond? Well, $7 times 10 bags, $70 at that point. Oh, that's not very dark, is it? 70 at that point. If they charge 6, they will sell 20, and that means they will have $120 in the cash register. If they charge $5, they will sell 30, and that means they will have $150 in the cash register. If they charge $4, they will sell 40 bags. 4 times 40, $160. Now, suppose someone says, wow, the more we drop the price, the more money we're bringing in from selling these almonds, let's drop it to $3. Well, we drop it to $3, consumers will buy 50. Yes, they're buying more, but how much is in the cash register at the end of the day? 3 times 50? 150. 2 times 60? 120. 1 times 70? 70. You notice another pattern here? At very high prices, at prices that really are too high to support the market, consumers have a very elastic response to dropping the price. So you drop the price a little, you sell significantly more, and you bring in more money into the cash register, 70, 120, 150. At the very, very lower end of the price range, where it's inelastic and consumers don't react that significantly, you can continue to raise the price from 1 to 2 to 3. And you don't lose that many sales. In fact, you increase the amount of revenue coming into the cash register, 70, 120, 150. Every demand curve for every good or service will follow this pattern, with the lowest amounts of income, the lowest amounts of revenue coming into your cash register happening at prices that are ridiculously high and prices that are ridiculously low. They increase the amount of revenue you make, increase to a point. And at some point, you've maximized your revenue. And guess what point that is? We maximized our revenue of $160 at a price of $4, which happens to be the unit elastic price where consumers have a proportional response and a price elasticity equal to 1.0. You'll always have those patterns. You want more patterns? I'll give you another one. Unit elastic price, $4. Where does the demand curve hit the vertical axis? At $8. 4 is half of 8. What is the unit elastic quantity? Well, at $4, we're going to sell 40. Where does the demand curve hit the x or horizontal axis? 80. What's half of 80? 40. This is full of patterns. Your unit elastic quantity will always be halfway between wherever the demand curve hits the x-axis and 0. In this case, 40. Your unit elastic price will always be halfway between wherever the demand curve hits the y-axis and 0. In this case, 4. If you charge $4 for almonds in this store, you will maximize the revenue possible from this product given consumers' current purchase desires. Sometimes determinants change and curves shift, as you well know, such as holidays or the availability of a good substitute for almonds, maybe hazelnuts. But given current demand, $4 maximizes the revenue that the store will be able to bring in for this good. Now, does that mean that is the price they should charge? Absolutely not. Because while this maximizes revenue, we do not know what it costs the store to obtain that number of bags of almonds and put them on the shelf. It may be that they have to buy in lots of 30, so in order to have 40 bags, they have to buy 2 lots, and they end up with extra. It may be that by putting that many almonds out on the shelf, they have to have fewer walnuts or pecans, and maybe they make a higher profit on those 2 things. We don't know what it costs the store to provide 10 bags of almonds, 30, 40, 60, 80. So we cannot make a judgment that that this is the best price, because we don't know what their profit will be at each price level. We only can say with certainty that given current consumer demand, this will be the highest amount of revenue, the highest money coming into the cash register at this particular price. Well, I hope that helps to clear up some of the issues, some of the math surrounding elasticity. If you're asked to simply calculate elasticity between 2 sets of variables, you don't need to graph it out. In fact, if we go back to the original idea here, where I said at $6 they sold 20 bags, and at $2 they sold 60 bags, you can determine the elasticity between those 2 points, which is the normal range within which the store sells the good, without drawing a single line or any graphs. You've got 2 prices, you've got 2 quantities. Run your numbers through the formula. And if that's the price range within which the store normally sells the good, you now have a way to determine whether the good is elastic or inelastic, or unit elastic for that matter. Okay? All right. Tom Simmons signing off, hoping that was helpful.